All right, welcome. We are going to answer this question on projectile motion. The main aim of this question is the fourth part of the question, but however, we'll still answer the rest of it. So the question says, the body is projected from the ground at an angle of theta to the horizontal, with a velocity of 30 meters per second. It reached a maximum height of 11.25 meters. Calculate I, the value of theta, I, the time taken to strike the ground, I, the range, IV, its velocity is 2 seconds after projection. So we are quickly going to answer this question. So solution, we will first write out the parameters we've been given. We've been given the maximum height, h, equals to 11.25 meter. We've been given the initial velocity, u, equals to 30 meter per second. That's all we've been given. So to calculate the value of theta, we are going to use the formula for maximum height, since we have the value for maximum height. And the formula for maximum height, before you write formula for maximum height, you first have to identify the kind of projection this is. There are about three basic kind of motion under gravity. We have the vertical motion under gravity, we have the projectile motion. Projectile motion is of two. We have the incline and the horizontal projection. So this is an incline projection. So the formula for maximum height for an incline projection is u square sine square theta over 2g. So you see, we have u, we have g, we have h. It's only theta that we not know. So with one unknown, we can find that one unknown using the rest. So what we need now is substitution. So let's substitute. Our h is 11.25 equals to our u is 30, so that will be 30 raised to the power of 2 sine square theta. This sine square, a lot of students always substitute it wrongly. You don't first do this sine square theta means you first evaluate sine theta. Whatever is the value for sine theta, you now square it. Not the other way around, you first square the value of theta before you now find the sine. That's not how it's done. So that's sine theta. You put it in bracket all square divided by 2g. That's 2 times what? 10. Acceleration due to gravity is approximately 10 meters per second square. Okay, I can divide this thing. So I'll try to make sine theta the subject of the formula. So sine theta, sine square theta will be equals to, you cross multiply that will be 11.25 times 20. Okay, divided by 30 square is 900. So if you evaluate this quickly, you then have that your sine square theta equals to 0.25. So if you take this square to the other side, it becomes square root, or you say take square root of both sides, you now have that sine theta will be equals to square root of 0.25, and square root of 0.25 is 0.5. So if you take sine inverse of both sides, making theta the subject, theta equals to sine inverse. Your calculator, scientific calculator, can process that. Sine inverse of 0.5, and sine inverse of 0.5 is 30 degrees. So the angle theta is 30 degrees. So I will proceed to answer the second part of the question. So we use a fresh page to do that. So the second part of the question, II. So we should calculate the time taken to strike the ground. Time taken to strike the ground what that means, total time of flight, capital letter T, means the total time the projectile body has spent in the air. And the formula for total time of flight is given as T equals to 2U sine theta over G. So we know what theta is, we know our U and G, so it's just a simple substitution. So that will be 2 times 30 sine what? 30 divided by 10. So if you do that, your T is going to be 3 seconds. So we do number 3 part of the equation, I said we should calculate the range. And formula for range means the total horizontal distance covered by the projectile body. So formula for range equals to U squared sine 2 theta over G. Most students also always have substitution problem here because of the 2 theta, but it's not that really difficult. So R equals to 30 squared sine 2 theta means 2 times the value of theta. That's 2 times what? 30. So instead of finding sine 30, we end up finding sine 60 divided by that. So that will be 900 sine 60. You're finding sine 60, not sine 30 again, over 10. And when you do that, you'll be having approximately 77. Approximately 77.94 meters. So now the main part of the question for this comes IV. IV says we should calculate the velocity 2 seconds after projection. That's V of 2. V of what? 2. So now to calculate this, we are going to find the resultant of both the vertical and the horizontal component of the initial velocity. You know, for a projectile motion that is undergoing that is an inclined projection, something that goes like this and come this way. Now for this kind of motion, an object undergoing this motion is going both forward and upward, and then on the return path, it's going both forward and downward. Now, so that means the initial velocity, it was projected at this angle like this, theta, but it ended up taking a parabolic path. So here is labeled U subscript Y, here labeled U subscript X, that's the vertical, horizontal component and the vertical component. So now one thing you have to know is that U subscript X, the vertical component of the initial velocity, is constant. What I mean by it's constant is that the value doesn't change. Whatever initial velocity it was projected with, the vertical motion, the horizontal movement of that projectile will be constant. It's only the vertical movement that will change, that will differ. Because as it's going up, it will reach a certain height. At that maximum height, its vertical component of velocity becomes 0. V subscript Y equals to 0 at maximum height. Then as it starts to come down again, V subscript Y start gaining velocity again. But in overall, the horizontal part components of the velocity remains constant. So if you want to calculate velocity after 2 seconds, what you are going to do is you are going to calculate the resultant of the vertical and horizontal velocity. And the resultant, V subscript R, is given as a, we use Pythagoras theorem to do that, is given as a V subscript X squared plus V subscript Y squared. So what is now left is for us to find V subscript X and V subscript Y. Now for the vertical horizontal component, U subscript X is given by the relation U cos theta. So if you find U cos theta, that is 30 cos 30. If you find 30 cos 30, 30 cos 30 will give you 30 cos 30 will give you 25.98. 25.98. That's what is going to give you 25.98 meter per second. Then, and this value is constant throughout the motion. The vertical component of the initial velocity, the horizontal component of the initial velocity is constant throughout the motion. So now it's only the vertical component that changes. So for you to find its velocity after 2 seconds, you use the relation. With the relation, you know that V, equation of uniform motion, V equals to what? U plus. Whether you use plus or minus, depending. U minus GT. You know, for incline projection, when it's going up, it is negative G. When it's coming down, positive G. But whether you use positive or negative here, it will reflect when you are calculating the final resultant. So in this place of U here, we are trying to find V subscript Y. So in this place of U subscript, this place will now change it to U subscript Y. So in this place, that will be now U sine what? Theta minus GT. So if you calculate that, that will be 30 sine 30 minus 10 times. They say velocity after 2 seconds. So you substitute there 2 seconds. So if you do that, take new whiteboard. If you do that, what were we calculating? V subscript Y, 30 sine 30 minus 10 times 2. So if you do that, sine 30 is 1 over 2, and 2 divide that 15. 2 divide that 15. 15 minus 20 will give you minus 5. So that means, okay, we'll still find out. So now our resultant velocity after 2 seconds, resultant velocity after 2 seconds will be, open bracket, that's V subscript X squared plus V subscript Y squared. And what is our V subscript? What is our V? Our Vx, which we found, was 29. Was what? What was it? 25, sorry. It was 25.98. Then we square it plus minus 5 squared. So when you do this, minus 5 squared. When you do this, this is when you do this calculation. Okay, let us just finish it. Well, let us not finish it. Let me just write it. If you do that calculation, you'll be having 26.46 26.46 meter per second. So that is how we do this one. It's not really that difficult. So one for online classes and tutorial, you can visit my description. You can read the description to see how to contact me. All right, thank you.